Hi everyone, it's Miss Thomas, and today we are looking at some more factoring. So do not copy this down. This is both in your textbook, and I have a little handout for you to put into your notes so that you don't have to write all this. But these are some different techniques for polynomial factoring. Obviously, like I said earlier, we always want to factor out the GCF. Our quadratic trinomials, we really want to remember that they're going to factor into two binomials. Perfect square trinomials, we'll look at those examples today. But it's when this trinomial form, reigning in standard form, will factor into two of the exact same factors. Difference of squares should be somewhat familiar. It's when you have a perfect square minus a perfect square. It factors into the square roots of those things. One's plus, one's minus. Please don't do it when it's a square root. Factor by grouping. This builds on what we were talking about yesterday. When you have four terms, you're going to want to use factor by grouping. So basically you group the first two, group the second two, and just factor those smaller terms. And then the sum of difference of cubes is another formula that you need to memorize. So let's look at some examples. We have factor k squared minus 18k plus 81. And we can do this, I'm going to show you sort of the shortcut way. We want to notice that this is a perfect square. This is 9 squared. Obviously, k squared is a perfect square. And then when we look at the middle term, that negative 18 is just 2 times 9. So we should be able to see that this is actually a perfect square trinomial. Its factors are going to be k minus 9, k minus 9. And you can do this a long way as well and figure it out. But a lot of times on standardized tests, they'll write the factors that way, as k minus 9 quantity squared. And so if you can memorize perfect square trinomials, you'll be able to factor them really quickly if you see that pattern. So another example, we have 64t squared plus 36t plus 4. And this goes a little bit more to that formula. And the formula is when you have a squared plus 2ab plus b squared. That factors into a plus b quantity squared. And so the a and the b are really the square roots. So you're looking for perfect squares at the beginning and the end. So the 64 is a perfect square. So this is like having 8t quantity squared. And then looking at the end, 4 is obviously 2 squared. The 36, when they say 2ab, it's 2 times your 8t times your 2. The 2 coming from here, the 8t coming from here. So that actually works because 2 times 8 times 2 is 36. So this is a perfect square trinomial. So that's just going to factor right into t plus 2 quantity squared. So that's the benefit of knowing if it's a perfect square trinomial, and you don't always have to write this middle step, right? You don't need to write that out if you know that the square root of 64 is 8 and the square root of 4 is 2, and then when you multiply 8 times 2 times 2 again, you get this middle term, then you can go straight to this. So we want to factor 9x squared minus 36. This is the difference of squares. So again, we're looking for perfect square relationships. So 9 is a perfect square, 36 is a perfect square. Anytime you have a binomial where you have a perfect square minus a perfect square, it's going to be the difference of squares. So you take the square root minus the other square root, so 3x minus 6, times the quantity where you take the square root plus the square root. Okay? So the reason that is only a binomial, and you guys do need to get in the habit of checking, if you were to multiply it out, when you take 3x times 3x, you obviously get 9x squared. Sorry, my stylus is being a little wonky today. 3x times the 6 is going to give you an 18x. Negative 6 times 3x is going to give you a minus 18x. And that's right there why the difference of squares works. Because these two terms are going to cancel out. And you'll just be left with the 9x squared minus 36. So this is how you check, but this is your answer. So here's another one where we factor. We've got 2x to the 4th plus 6x to the 3rd minus 18x squared minus 54x. First thing you always want to look for is a GCF, particularly in a polynomial this big. And when you look at all the terms, 2, 6, 18, 54, all divisible by 2, x to the 4th, x to the 3rd, x squared, x to, and just an x, they all have an x they can give up. So then you are left with 2x times x to the 3rd will give you that term that you started with, plus 2x times 3x squared would give you the 6x to the 3rd, minus, oops, not 18, because we're dividing it by 2 when we factor that 2 out, 9, and then x squared, we took an x out, so we just have an x left, and then 54 divided by 2 is going to give me a 27, and the x has been factored out. So this gets a little confusing when you have a GCF out front, but that's a multiplication sign, sorry. We still have this we want to factor. So we're going to kind of ignore a GCF for right now, and whenever you have 1, 2, 3, 4 terms, you want to do factor by grouping. So this goes back to what we did the other night. So I'm really just going to look at the x to the 3rd plus 3x squared minus 9x minus 27 for now. And I'm going to group the first two terms and the last two terms. But be careful. When you group the last two terms, if you have a minus here, change it to a plus and put the minus on the inside, or you're going to have some problems with your signs. So, looking at my GCF for just the first two terms, x to the 3rd and 3x squared, they have an x squared in common. And when I look at what's left, I see an x plus 3. Looking at my next two terms, because this leading term is a negative, I want to factor a negative out. 9 goes into both of these, so I'm going to pull out a negative 9, and I am left with an x plus 3. So factoring that negative out is going to change that to a positive. So now I want to look big picture again, and when I look at the whole expression, I have an x plus 3 in each term separated by a subtraction. So I'm actually going to factor out that x plus 3. So when I pull that x plus 3 out, I have this left and I have this left. So I have x squared minus 9. Now, a couple of tricks are happening right now. X plus 3 is definitely prime, but x squared minus 9 is a difference of squares. So I need to factor that again. So I have x plus 3, and then x minus 9 becomes x minus 3, x plus 3, following that pattern from the previous slide. The other thing that we don't want to forget about is that we factored out a 2x into the first step, and that guy cannot just disappear, so he goes out front. Now, we're going to go ahead and write this a little bit more neatly. We want the 2x. We have x plus 3. But we have x plus 3 as a factor twice, so we're just going to write that squared. And then we have x minus 3. And this is the factored form of that polynomial. So, we want to factor. Again, sorry for the ugly writing. My stylus is very weird today. We have 27x to the third plus 64. So when we look for a GCF, there's no GCF. There's nothing that goes into 27 and 64. There's only one term that has an x, so there's no GCF. This is going to be the sum of cubes. So the sum of cubes is a formula, and the formula is on that piece of paper that you have, but the formula goes a cubed plus b cubed equals the quantity a plus b times the quantity a squared minus ab plus b squared. So this is tricky, and you have to memorize it. And we can talk a little bit more tomorrow about ways to memorize this. The other trick is that you're not going to have the 27 and 64. You need to write those as their cube roots. So 27 is really 3 squared, or 3 cubed, so 3x to the third power plus 4 to the third power is really what 27x to the third plus 64 can be rewritten as. So if we're following this pattern, that's going to factor to 3x plus 4. Then it's going to be 3x squared minus 3x times 4 plus 4 squared. So this is your a squared, this is your b squared, and this is your a times b. So bring that down, 3x plus 4. You want to simplify. The 3x squared is going to be 9x squared minus 12x plus 16. And that is your factored form. Your U-try is going to be to factor 27x cubed minus 64. So very similar, but there's some differences. You're going to want to use that formula sheet that you're given in class or that's posted online.